We are at challenge 5. This is the second hole on planet 2. It says, observe the forces and how the vector sum, or the net force, affects the resulting motion. Now this is actually going to call upon how to work with vectors with themselves and get the net direction, which is actually, in essence, adding vectors. And adding vectors, as you know, goes tip to tail, and then you draw the resultant one from the point of origin. And this is going to kind of showcase that with the physics visual. It's a way that we can get an understanding, instead of having all of these different force vectors on the ball, what is the net force that is acting upon it, competing against the forward motion of the initial force input, which then has the velocity through the rest of the travel to describe its motion. Okay, so here's an example about how strategy come into play with some of these levels where you have drastically fluctuating atmospheric densities. I have 2 pathways that I can take, and each of these 2 pathways have substantially different things. And you can see these are the power-ups, and there's going to be a label once you go to top view that talks about what these power-ups do. So we can see that I've got 2 energy refills on this left side, 2 mulligans, and then that path. They look relatively the same distance. This one has an energy recharge right at the same time, but I don't get this middle one. And what I suspect might be able to happen is, or what might happen is that as I get towards the center, where I'm going to hit towards the center over here, the atmospheric density is going to increase substantially if I look at the graph, which it will. So you can look at after the first shot, it's going to be up there high. That means that once I get over here to the right side, I'm going to have a tougher time getting at a distance than going over here and getting this energy recharge and then traveling distance. So let's see how that strategy might work out. If you're doing multiplayer, having these different pathways allows for a better dynamic gameplay between the kids. Okay, so I'm going to choose, let's just choose the left path for now. See where I can get it. All right, so I'm going to try and get this power up right here. Let's see how that works out. I have some wind. It is combating my distance, so maybe I want to go just a little bit farther. All right, drag it back. It looks a little bit to the left, and it's in the same put. Okay, so right here we're seeing the vector component addition and the resultant vector drawn tip to tail. So I have, this is in a 3-dimensional space, and this is actually viewed, you know, through facilitation. You might want to do a 2-dimensional representation first to sort of see the tip to tail addition, and then in the 3-dimensional space you just are adding on another axis, and you have 3 coordinate points, the X, Y, and Z. And you can notice that from the one visual that we had the previous hole, we just had the force vectors labeled on the ball, and then we picked the gravity vector, which is the one facing down, to keep that as our stable frame of reference, and then the rest of the vectors sort of move tip to tail to eventually get to the final one, which then you draw from the center of mass straight out to that last vector, which was our green one right here. And so that resultant vector that we are seeing that just got drawn is the net force that is opposing the ball's motion. Close but no cigar. Okay. All right, so now I have this challenge. I have an incredible amount of atmospheric density right now. I'm going to see if I can land it right on that lander right there. I've got a little bit of wind taking me to the right. Let's see if my high loft will make it not bounce too far off. Here we go. It's going to go way up and fail. So it put me back on shore, which is a drop ball, which makes sense. And now I've got actually substantially less atmospheric density, so I'll be able to hit this quite far. I'm going to try and hit it just back onto the right course. Get a little bit of right wind, should be okay. All right, so I cleared the lake. There we go. Okie dokie, so I'm at thick gravity, so I'm not gonna be able to hit that far with the wedge. Let's see how far I can get with the iron. So the iron looks like it's gonna be safe. It's gonna have a high loft, which means it won't bounce as far. The driver tends to, with the low loft ankle, make it skip like a skipping stone pretty far. All right, so this looks about right. Ooh, that's a good shot. Okay. Ah! Gypped. I got gypped. I don't like that one bit. Okay, so now I am at challenge number 5. Yeah. Okay, so now from the net force, what can be inferred about the flight of the ball? So let's go through and see what type of suggestions they're having for the answers. When the net force of the ball is changing, the motion will not. Okay, so if the net force of the ball is 0, the motion will change. So this seems like it's going to be incorrect just because of the fact that if I have 0 net force, that means it's probably not going anywhere. You can imagine pushing on a wall is similar to that description. So when the net force of the ball is not 0, the ball will change its speed and or direction. So this is saying that it's going to have a change in velocity, or separately, it's going to have just a change in its speed and direction. This actually sounds closer to what we're thinking, because the net force, if it's not 0, there is going to be things changing. Its direction, its speed, all of that is going to be affected by it. The net force has no effect on the motion of the golf ball. We already know that that's not true, so I really narrowed it down to these two right here, and we can kind of see that a changing net force, it will be positive. It may go to 0, but it may be positive at some point. So saying the motion will not change is inaccurate. So I'm going to go with this one, and we shall see if that's correct. It was correct. Fantastic. One other thing to note is that if a student misses a question, they will keep getting a reoccurring question until they get it correct. This will allow for multiple playthroughs and also mastery of the actual 9 questions that we're asking them.